Hello everyone, welcome to our 7th International Conference on Natural Resources and Sustainable Environmental Management and 4th International Conference on Water Problems in Mediterranean countries. Today we are welcoming various researchers from different countries and they are here to share their valuable insights for us. This is session 1, room 1, and first Professor Dr. Haluk Akgün is here for us to share his insights.
My topic today is geotechnical considerations in sealing of openings in nuclear waste repositories. It's a general concept actually on nuclear waste disposal. And when we dispose the waste in geological repositories, the aspect of this talk today is how do we seal these borings to protect the environment from radionuclide migration down the road. So this is an artist's concept of what a nuclear waste repository will look like in the future. At the surface, we have surface waste handling facilities. We are putting the waste in encapsulated solid waste drums, then in overpacks, then in overpacks in vaults. And between the tunnels or access ways and the vaults, we need to seal these with backfills. Expandable cement grout formulations, bentonite sand formulations, or bentonite on its own are recognized or are recommended for these sealing materials. And the problem is when we seal all these access ways and tunnels and shafts, we will have some axial stresses on these boreholes. Due to these axial stresses, we will have shear stresses at the interface, and these shear stresses should not exceed the shear strength, or we will lose the containment objective. We will lose the plugs. So in short, the most likely sources, what are these likely sources of axial loading on these seals? They're either hydrostatic pressure due to a water column on them, or due to the heat generated subsequent to waste and seal emplacement. So due to these effects, we're going to have axial stresses on these seals. And what are these seals going to do? They're going to induce shear stresses along the interface. And if the shear stresses are excessive, they are exceeding the shear strength, we will have the loss of containment, and we could cause slippage of these seals. And at the end, we're going to have increased permeability, and we're going to have inadequate interface shear strength from a geotechnical point of view, we can say. Today, I'm going to be talking about a general subject on bentonite sand seals. I have worked on expandable cement grout formulations as well. But here today, I'm going to give you some of the research insights we had in terms of testing these bentonite sand seals. So the objective of this section is to determine an optimum compacted bentonite sand mixture for borehole isolation through performing compaction and flow tests. And additional objective is to investigate the stability of these boreholes sealed with bentonite sand mixtures. And of course, these are for the scenario of they are emplaced in the vicinity of an underground nuclear waste repository. And after we select the optimum bentonite sand seal, we have tested the swelling, mechanical, and shear strength of these seals through analytical and numerical analysis. And the basic aim of this research, the final, the meaty part, let's say, that I'm going to talk about, is what is the optimum seal length to radius ratio to overcome all these axial stresses. And these axial stresses might be due to a water column accumulating on top of these borehole plugs, or due to the heat generated subsequent to the emplacement of the waste that is going to generate high temperatures. So the bentonite sand geotechnical characterization testing, if we go into that, the bentonite contained at least 90% of montmorillonite, the bentonite that we utilized through these tests. And this is giving, table 1 is giving the geotechnical index and engineering characteristics of the natural bentonite component of the compacted bentonite sand mixture. So in short, specific gravity is 2.74. The liquid limit that we had was 450%. Plastic limit was 35%. The plasticity index was 415%. And the positive cation exchange capacity was, in terms of milliequivalent per 100 grams, was 100. So the sand component, the well-graded sand component used in this study, possessed a hydraulic conductivity of 10 to the minus 4 meters per second, specific gravity of 2.64, void ratio of 0.45, and a maximum compacted dry density of 18 kilonewtons per cubic meter. And for the initial testing part, we tested 4 kinds of compositions. They possessed 12.5, 15%, 17.5%, and 20% bentonite at various molding water contents. The result of the standard compaction test of one of our tests we had for the 15% bentonite sand mixture is given by this figure 2. And we have dry unit weight versus molding water content. The optimum moisture content was about 16%, and the maximum dry unit weight was about 16 kilonewtons per cubic meter. And these are the 80% and 100% saturation curves. Then what we did was we tested all these mixtures under standard Proctor compaction tests, and this table 2 gives a summary of their optimum moisture contents and the maximum dry densities that we attained. So going from 12.5 to 20% of bentonite content, we increased the optimum moisture content increased from 15.80 to 16.29%, and the maximum dry unit weight decreased from 16.20 to 15.10 kilonewtons per cubic meter. Then, excuse me, the next step was to do some permeability testing. So we did some compaction permeameter tests, and this is the setup that we had. And according to the setup we could test 4 samples at the same time. We had an evaporation bridge to compensate for the evaporation we had in the laboratory due to the high temperatures. And we also had a de-airing tank, distilled water tank, and a vacuum pump, obviously, to pump the water in the de-airing tank. And we could do, like I said, 4 tests at the same time. And for the falling head test, for the head falling from H1 to H2, from a time T1 to T2, this is the general equation used for falling head tests. So we calculate the permeability or the hydraulic conductivity or the coefficient of permeability of all these 4 samples. And at the end, we obtain the permeability. And these are the hydraulic conductivity of the 4 samples that we tested. We tested the samples at about 2% wet of the optimum moisture content, and bentonite content going from 12.5 to 20%. The hydraulic conductivity decreased from 8 times 10 to the minus 9 to 3 times 10 to the minus 10 meters per second. And at the end, we chose the 20% bentonite content for a bentonite sand mixture because it attained the regulatory limits of 1 times 10 to the minus 9 meters per second hydraulic conductivity. And that's why we selected the 20% bentonite content as our optimum moisture content. So the results show that the mean hydraulic conductivity of the sample with a bentonite content of 20% was equal to about 3 times 10 to the minus 9, 10 to the minus 10 meters per second, which satisfied the regulatory requirement for a compacted clay material, 1 times 10 to the minus 9 meters per second. Upon determining the optimum moisture content, possessing a bentonite content of 20%, swelling, unconfined compression, and direct shear testing was performed on this mixture to determine the swelling pressure, Young's modulus, and shear strength parameters. Then we wanted to do some analysis of the seal log interface strength of bentonite sand seals to determine eventually what the length to radius ratio, what the optimum length to radius ratio would be for expected water columns on these plugs. And this section analyzes the stability of an axially loaded compacted bentonite sand seal and placed in a borehole or shaft in the vicinity of a high-level nuclear waste repository. The geotechnical properties of the optimum mixture with a bentonite content of 20% were utilized in the stability analysis. And this gives the mechanical interactions of a borehole plug emplaced within the rock, host rock. And this figure gives the geometry and coordinate system utilized for stress calculations for an axially loaded seal in rock. If, say, we emplace a borehole plug, and in our case, we are using compacted bentonite sand seal. And if we do that, we use this, put this in an coaxial hole within rock. And so think about this as a cylinder. And at the middle of the cylinder, we have a coaxial hole, and we are plugging that with compacted bentonite sand seal. And whatever we have as the axial load, and the axial load can be generated because of the water column or because of the thermal stresses due to high heat generating from the nuclear waste. For these, we have sigma z, which is the axial stress applied to the seal. And for some coordinate system, z is equal to 0 at the top, loaded end of the plug. Z is equal to L is the bottom of the plug. So what happens is when we have this axial load, we have some differential deformation of the plug. With that differential deformation, we have the stress transferring to the interface through shear stresses. And the inside radius of this system is A, and the outside radius is capital R. So our aim was basically solve for this shear stress distribution at the interface. And the most logical shear stress distribution is the exponential shear stress distribution, where we have the peak at the loaded end of the plug, and we have the minimum value at the lower end of the plug. And this exponential shear stress distribution, we wanted to calculate what that was. And sigma z is the axial stress applied to the seal. Tau is the shear stress at the seal rock interface. Sigma s, and we also have the swelling stress due to the compacted bentonite sand seal. Or in case of a cement grout, we have the swelling stress due to the swelling of the cement grout. The same story kicks in there. Z is the axial distance from initial location of the loaded end of the seal. A is the seal radius. Capital R is the rock cylinder radius, and L here is this seal length. So as an axial stress sigma z is applied to the seal, differential deformation of the inclusion takes place, and load transfer occurs through shear stresses at the interface between the host and inclusion. Consideration of the axial force equilibrium of the system leads to the solution of the interface shear stress, and the peak shear stress is given by this exponential shear stress distribution, and these infinity signs in these equations indicate that these are applicable for the in situ state of stress, and where R over A goes to infinity. And sigma z is the axial stress applied to the plug. Alpha is a parameter given by equation 2a, next page. It's a tangent hyperbolic function, so it's an exponential distribution. L over A is the plug length to radius ratio that we are shooting for eventually. Gamma is given by this equation, where we have some parameters as the Poisson's ratio of the seal, Poisson's ratio of the rock, and alpha here is given by this equation here, where in these equations, L is the seal length, ES over ER is the ratio of the Young's moduli of seal and rock, VS and VR, nu S and nu R are the Poisson's ratio of seal and rock, RC is the critical radius beyond which the shear stresses and axial displacements in the rock are considered negligible. A and R are the seal and rock cylinder outside radii, respectively. So this RC implies that we have, at a certain distance within the rock, we have the shear stresses. We can have the shear stresses considered negligible, and that is the radius, critical radius, that we put in these equations. If we put the entire radius here, we don't have a logical result. And we have used the Moore-Coulomb shear strength equation that we have here, and it is the conventional Moore-Coulomb equation. So cohesion, angle of internal friction, and whenever we have normal stress at the plug and rock interface, and this normal stress is a function of the axial stress as a function of the cement swelling pressure, where C is cohesion, phi is the angle of internal friction, and then sigma NP infinity, which applies for an in situ state of stress, is peak normal stress across the seal rock interface for an in situ seal in rock. And we have to define this normal stress, and this is the most simplest way I can express it. It can become more complicated. So the peak normal stress across the interface due to the sigma z, which is sigma NP infinity, for an in situ seal in rock may be expressed as a combination of the peak radial stress and swelling stress. So this is eventually the equation, sigma rp, which is a function of the normal stress multiplied by alpha, and alpha coefficient was given here by equation 2b, and sigma s is the cement swelling pressure. So once we get the normal stress, and this normal stress is also distributed in an exponential form by this alpha, and the peak of that occurs at the loaded end of the plug. So the factor of safety, we know our shear stress defined by this equation. We know our shear strength. We know our shear stress defined by equation 2. We have our shear strength defined by equation 3. So we can calculate the factor of safety of these seals by simply dividing the shear strength by the shear stress. Then we also wanted to analyze what happens, in the real case if we pour these plugs in situ, and what is the length to radius ratio that we want to shoot for. And let's use water columns of 100 meters, 200 meters, and 300 meters, and let's see the stability of these bentonite sand seals due to these effects. So this figure gives a factor of safety in regards to plug slip as a function of factor of safety as a function of plug length to radius ratio for three kinds of water heads or water columns for 100 meters, 200 meters, and 300 meters. 300 meters is a little bit extreme, but we want to try and push for the most extreme case that we might have in a situation like this. And as you can see here from the factor of safety equations, for water column of 100 meters, there's no problem. We go up to 1.5 for a plug length to radius ratio of, let's say, 10. But for the same thing, for 200 meters, this goes down to about, 1.15, something like that. But for 300 meters, for the most extreme case we can think about, the factor of safety for this was about 1.03. So we concluded that we need to have at least plug length to radius ratio of 10 to attain a factor of safety that is barely enough to satisfy non-slippage of the plugs or the stability of these bentonite sand seals. So summary of conclusions. The objective of this study is to investigate an optimum compacted bentonite sand mixture for the isolation of underground waste repositories through performing compaction and flow tests. The results of the compaction per millimeter tests led to a recommendation to select an optimum compacted bentonite sand mixture having a bentonite content of about 20% to satisfy the minimum regulatory hydraulic conductivity requirement. Analysis of seal rock mechanical interaction in regards to reduce the possibility of seal slip led to a recommendation to utilize a bentonite sand seal length to radius ratio of about at least 10 to attain a factor of safety of about 1.03. And these are the references I have utilized, and I think I did my presentation on time. I'm 1 minute late, and thank you for listening to me.
Thank you very much, Professor Dr. Haluk Akgün, for your insights and for your presentation. It was a pleasure to lesson, and it was a pleasure to observe your conclusions and everything. Especially, it is also my field, geotechnics, so it was a pleasure for me as well. Thank you very much.
Thank you, Professor Saad Fırıncıoğlu.
Our next presenter is Professor Dr. Orhan Gemikonaklı.
Hey, good morning. Firstly, I would like to thank the conference organizers for inviting me as a keynote speaker. What I would like to talk about is the renewable energy in its role to combat climate change, global warming, because there is some misunderstanding, although it's used as a key word, as if it's the ultimate solution, but there are some misunderstandings, some problems to know before we rely too much on renewable energy, or at least analyze the situation better. So I don't want to go much into the known terminology quickly. Climate change refers to long-term changes in average weather patterns, such as changes in temperature and its effects. Renewable energy is what we can get from natural resources that can be replenished, things such as sunlight, wind, hydropower, geothermal heat, biomass, and so on. And of course, sustainability combines all this together, and it means the ability to meet the needs of the not only present generation, but ensure that we won't compromise the ability of future generations to meet their own needs. So climate change has some key aspects, quickly just to name them: global warming, shifts in weather patterns, rising sea levels, ocean acidification, biodiversity loss, all well known by its terminology, so no need to redefine them. We come to our point. Key aspects of renewable energy will be solar, wind energies, hydropower, geothermal energy, biomass energy, and of course, it's something we use and would like to increase the use of to reduce dependence on fossil fuels, mitigate climate change, and promote sustainable development, because it's something low emission and it has minimal environmental impact. It's this last point that I will emphasize, I'll talk about. Is it really minimal environmental impact? Is there something we don't see? And sustainability, well, we can talk about environmental sustainability, but also social, economic sustainability. And these three are interlinked. We can't separate one from the other one. If you can't sustain the environment, then socially, economically, you see problems as well. Okay, greenhouse effect, climate change. Well, greenhouse effect is the reason behind it, but climate change, global warming. We have recently, maybe in the past few decades, have started to discuss this problem, but it's really something which is 200-year-old problem. And it's not only now that we know it, some scientists realized it long ago. Well, the first calculation is possibly the one done by Joseph Fourier. He suggested that a planet like ours, the size of our Earth, at our distance from the sun, should be much colder. So he proposed that something in the atmosphere must act as an insulating layer. So it's not as cold as he calculated, he expected. Then 1856, Ernest Foote discovered the role of carbon dioxide and water vapor in Earth's atmosphere in trapping heat, which is a well-known fact today. In 1896, Swedish scientist Svante Arrhenius used Joseph Fourier's calculations to publish a groundbreaking paper. And he predicted that changes in atmospheric carbon dioxide could significantly alter Earth's surface temperature. And that's, of course, through the greenhouse effect. So what Joseph Fourier started reached to another height before the start of the 20th century. And then in 1938, another scientist, Guy Callender, linked the rise in carbon dioxide levels to global warming. So the rise in global temperatures confirmed these early warnings. We know now that Earth's temperature has increased by an average of 0.11 degree Fahrenheit per decade since 1850, which is about 2 degree Fahrenheit over the past 2 centuries, which is alarming. Then in the last 20 years, we have seen a lot more work in the field. The causes and consequences of climate change have been extensively studied. Now we know that fossil fuels are the primary contributors to this global climate change, and they're responsible for over 75% of global greenhouse gas emissions and nearly 90% of carbon dioxide emissions. So the first thing to deal with should have been fossil fuels. Unsustainable resource use, unchecked urban development, and other human activities further exacerbate the problem. And the effects of climate change include higher temperatures in the atmosphere, more intense storms, longer droughts, warming and rising oceans, loss of biodiversity, increased health risks, and growing poverty and displacement. And all these are quite obvious today. We are living through all of this currently. So the work done scientifically, especially in 20th century, is extensive. However, the actions taken don't match the work done, don't match what's proposed by scientists, academics, and even practical work, technological improvements. We have some tools, means of combating climate change, but not necessarily political will to enable the use of all these technologies positively. So theoretical work is there, technological innovations, adoption of environmentally friendly practices all emerge, but not necessarily sufficiently used. We have always heard of the use of renewable energy and how it will reduce carbon dioxide emissions, how to combat climate change. But even there, we don't get the full story. We are not told the full story. I'll come to that point before the end of the presentation. Yes, there are advancements in technology, in theoretical work to make clean energy possible, or at least it's promising. But even today, renewable energy is still not a dominant solution in combating climate change. Although it is proposed, it is suggested, it is understood, even if this story is not fully told. But in practice, its use is limited. So, why do I say so? Of course, I'm not against renewable energy, or of course, we use them, we should use it even more. But it's not without its challenges. And this is what people usually underestimate. That's what I would like to highlight today. We know the hazards of wind turbines. They pose environmental risks, harm to wildlife, fire hazards, visual pollution. Yes, some of these problems may be reduced and as work continuing. Bioenergy may lead to water scarcity, so it's an important setback because you need to grow more to use for energy production. But my main concern is on electric vehicles, what's not explained sufficiently. Yes, they do have ecological benefits, but there are concerns. What are these? For the production and disposal of batteries is a serious challenge because the production itself generates so much pollution that it is estimated that to offset the pollution generated by the production of a battery or an electrical car, you have to use the car for about 9 years. And after 9 years, if the battery still survives, you can start benefiting the environment from the use of electric vehicle. So the environmental impact of battery production may offset some of the benefits of electric cars. We have to put into our calculations. Of course, the disposal is another problem. Most countries are not able to do it properly, and especially for countries like Cyprus, small island, shouldn't be done on the land here, maybe exported back where it's bought from. Well, we can say the same for other renewable sources as well, from wind to biomass. So what I want to bring to your attention is that these issues require further investigation because the story is not completely told. Okay, we said batteries may not be the best solution, but of course, we can use batteries effectively if we can diversify renewable energy sources. Then we can have a more sustainable future. What do you mean by that? Well, if you rely on solar energy as a renewable source, then it won't be sufficient. Then we'll have problems with the electrical grid as well, as it is the case in northern Cyprus. But if we use different sources such as wind, and the biomass is questionable, maybe wave power, etc., then we can balance certain aspects of renewable energy and make it more efficient, more usable. Sustainability goes beyond, of course, energy production. Alongside proper use of renewable energy, we need to modernize water irrigation systems, especially in places like Cyprus, small islands, to improve soil management and practice responsible agriculture. This is not yet in place. There's very little done. So you cannot just rely on renewable energy, but have a wider view in addressing climate change. Again, water treatment plants must be more widely used. And of course, responsible consumption of natural resources is vital. Otherwise, we can't get the sustainability we aim. OECD's Sustainable Consumption Report states consumers can play a critical role in achieving climate and sustainability goals. And they go further and give some percentages. Their spending represents on average 60% of GDP in OECD countries, and changes in lifestyle and consumer behavior could reduce global greenhouse gas emissions by up to 70% by 2050, which is quite important, significant, and we don't really take into account. However, more support, they say, is needed to promote sustainable decision making. That's something else that seriously lacks in our environment. So we live in Cyprus, northern Cyprus, half of an island, a small island. The smaller the land is, the further complications of the problem. However, we have even more serious problems here because to understand the scale of the effects of global warming here, we need data. But we have lack of data. Even the existing data is not accessible. And that and effective policies hinder research alongside the lack of data. And if you don't research, you can't find possible solutions. I was a member of the Renewable Energy Committee. At the first meeting, I asked for data because we needed to plan the next year, what quota we'll give, at what level, etc. We couldn't get any data. Then eventually we managed to dig out some data that you could hardly call as data. So this is a serious problem. It's not only inability to record data, but also unwillingness to release data to those who would do research, would come out with possible solutions. When we look at the data we manage to dig out, it appears that solar energy consumption has reached its maximum potential in the region, because you can't use solar energy for 100% electricity production because of its nature. Because variable throughout the day, you don't get that 9. Well, use of batteries may relieve the problem a bit, but still not a solution, etc. We have about 450 megawatt fossil fuel-based energy production in the country. And a couple of years ago, what I noticed was that solar energy investments exceeded 100 megawatt. And then there were tens or more megawatts permissions given. I guess it must have reached 100 megawatt nowadays. Only a guess, because as I said, we can't reach the data. So if we say that around 25% of total energy investments are in solar energy, then it's important what percentage is contributed in production. If production is distributed throughout the day, that would be great, but it peaks at around midday, then to both ends it's less in the morning, and keeps increasing until midday, keeps decreasing again, and zero at night. So when you have the peak midday, at the same time, the need for energy, the consumption drops as well. So without storage, it becomes a real problem. So in calculating the effect of solar energy, we cannot rely on the capacity and what kWA is produced, but what is produced throughout 1 or 2 hours of peak production, because that will have more impact than the rest of the day. We don't seem to use advanced technologies. They failed in the beginning to give smart meters, make it compulsory. Of course, that means supply instability. We do get undesirable voltage levels in some areas, and this have consequences. Then we need to address the aging grid infrastructure. It has not been modernized for decades now. And if it's not done, solar energy itself would not contribute much. Again, we need to have a well-established, comprehensive energy policy, which doesn't seem to exist. We keep getting more electric vehicles, which is positive in a way. However, as we get electric vehicles, we have more solar charging stations, which sounds good again, clean energy. However, it has not been planned how this will be integrated with the electrical grid, and the calculations show that it may be a burden on the existing grid. So it's not just to add more generation, solar energy generating systems, but also to plan it, how it will be consumed, and it will be consumed, and to impose some limits on its production and usage that will meet not only the need, but the capacity of the existing grid as well. Interconnecting grid with larger grids, such as Turkey or Southern Cyprus, or the new Eurasia interconnection, which will connect Israel to Cyprus, Cyprus to Europe, will ease the problem. But unfortunately, there are political uncertainties. Although the Eurasia interconnection has started, I don't know how much progress made, but from Israel to Cyprus, work was in progress, which technologically is a good step, of course. I don't want to go into the political implications. I have concerns there, of course. Then it needs to be connected to Europe, and there are political problems not resolved yet. Interconnecting northern Cyprus and Turkey again is not working. It's not in place because of political problems. So without addressing these political uncertainties, again interconnecting Cyprus, North Cyprus, to other larger grids does not seem to be possible. So, to conclude, to address climate change requires more than just switching to renewable energy. Renewable energy is brilliant, is a good source. We must use it to its maximum, whatever we can do, but we have to take action in other areas as well, such as urban design, improve infrastructure, energy efficient buildings, and modernizing water use in agriculture and industry. These are all critical, not only for combating climate change, but sustainability as well. We do understand greenhouse effect. It's been 200 years we have been talking about it, but yet too little has been done so far, and I think it's much of what's done is too late. So we have to focus on what can still be salvaged. We can't give up. We still have a problem to solve. We have a lot we missed, we lost, but still there's a lot to salvage. It's obvious that scientific research, technological innovation are central to this fight, but we need to see political determination as well, which works the opposite direction. The local wars are further increasing the problem of climate change. While we wait for political determination in a positive way, it seems to have an impact, negative impact on the problem. Okay, thank you for listening.
Thank you very much, Professor Dr. Orhan Gemikonatlı, for your insights. Thank you for sharing your findings with us. And thank you for attending our conference as well. So our next presenter is Professor Dr. Alper Baba.
Dear Chairman, thank you very much for inviting me to this important Congress. Today I'm going to focus about the effect of climate change on groundwater resource of the region. As you see that groundwater is very critical and very important issue. And then at that time, 69% of the groundwater used for the agriculture, and then about 90% for industry and the other are domestic. But when we look at the water resource application, the data show that global water use has increased sixfold in the last 100 years. Dear my colleagues, when we are comparing the population and the water resource potential, as you see that each continent is different. For example, in Asia, we have a 60% of the population, but we have just like a 36% of the water resource. And then, for example, African is a people more than water resource. But for the North American is a no problem. But when we can see that the other side, we have many problems. We may come across many problems in near future. In 2050, it is predicted that 10 billion people live in the world. The meaning that we need the more water resources. Dear my colleagues, in here as the continental and then sector water use, as you see that for in here, European most water use for the industry side, But if you look at in the Asian side, especially African and then Asian countries use more their water for the agriculture. For example, 81% in agriculture, but European is 50% is for the industry. Generally, the results show that the most countries, more people now depend on the agriculture and then depend on the water resources. If you look at the global United Nations and the global goals for sustainable development, at that time, 2.2 billion people lacked safely managed drinking service in 2022. Again, in the same years, at that time, 3.5 billion people lacked a safely managed sanitation service. This is meaning that about that near the 500 million people, that have problem with the clean water use. And then the other big problem in the world now is the transboundary cooperation, transboundary boundary waters. We have transboundary surface water, and then we have also transboundary groundwater system. Only 43 out of the 153 United members sharing transboundary water has operational arrangement covering about 90% or more their shared river, lakes, and aquifers. At least 20 countries lack an arrangement for sharing transboundary waters at that time. And then, if you look at the history, that the history people used to, that they gain the water in the different application, but we saw that the water dams are developed in the water harvesting in the different civilization through the history. If you look at these maps, that the maps show that especially most of the power, that the hydropower built in the eastern Anatolian and then around to the, that the Mediterranean region. And then still we have some ruins about these dams. Still some dams was used in the world. For example, in the center of Turkey, we have some dams, like Hittite dam, the Karakoy. Still this dam was used. But after that, now is the people, the population increased. The people start to build the big dams. For example, like in China, we have a gorgeous dam for the sustainable of the life water system. And then if you look at the history, the way water use has generally been utilized for all the history. People collected individual domestic rainwater tanks. They used the wetlands area. They stored groundwater, that the underground system. They collected rainwater and treated water in the agriculture. They settled close to the water resources and then built many dams in the history. But also the people in the history, through the history, they use for the agriculture. For example, that most of the civilization located near the stream at that time, located in the wetland, and then they used the different application for their agriculture. This is some figure from the Egyptian and then the other part of the world they use for the agriculture system. If you want to go to the detail, I suggest that you should read this paper. This is mentioned about evaluation of the agriculture use in the millennia. But the treatment is very critical because this has affected the system. If you look at from ancient to present and future, treated what used in many civilizations. For example, the ship from the Mediterranean, people went to one place to other place, but in the ship they that they boiled water and then treated water and used water. Sometimes the water is contaminated and then they use some clay materials and then treated this kind of the water system. But after then, the sanitation, because many civilizations affected health problem, most of health come from the water problem because water quality. And then what we saw that, for example, the laundry system is starting like 3,500 years ago BC by Mesopotamian. And then after then, the technology be increased late time. But if you look at from 1,900 to 1,018, as you see that we come across many problems like influenza pandemic in 2019 and 2020. At the time, many people was passed away. In addition, this is very critical. As you see that if you look at the data until the 1950, population live about just life expectancy was 45. But after the 1950, as you see, the population going to be increased, and then the life expectancy is reach about 80 years old. And then this is interesting. Until the 1950, the population of the world about 2 billion, but now is that 8 billion. The meaning that the population of the Earth is going to be increased. You can just imagine, like at 50, 60 years, how the population going to be increased. The meaning that we need the most water, most high quality water. And then the other the problem, the other things is the climate change. And then in the climate change, if you look at the historical session, like at 60 million years ago, the temperature about 13 degrees. But as you see, that temperature will be going degrees for the time. And for the generally, we are living in the cool period of the Earth crust in 65 million years. You can imagine, like 30 million years ago, the temperature is about like 4 degrees in here. Dear colleagues, especially we can see that the temperature and the carbon dioxide is a parallel to each other, positive proportional. But at that time to come, as you know that in the histories we like a carbon dioxide values is like a 280 ppm, but sometimes in degrees. But generally in the history we can see that in the time shift about 600 years. In the 600 years the climate will be changed. If you look at all the data, last 2000 data, especially after the French Revolution, we have very good data because we have a very good temperature values, we have a very good pressure data, and then we have a very good monitoring system. As you see that in all the data show that the temperature is going to be increased in all the world. But this also affected the Mediterranean region. Mediterranean region, and this is the largest of the semi-closed European seas, is surrounded by the 22 countries. And then the population of the region is about 529 millions at the time. As you see that this is the place of the population and then and the urban center in the Mediterranean region. Dear my colleagues, and then also land use and land cover is important. You see that in North Pie, green one is more agriculture region, but still in the especially south of the Mediterranean region, as you see that the yellow, the meaning that the intensive aren't grazing. Still, they have a good field, but not too much agriculture. That because they need more water resources. But all the data show that the temperature is going to be increased, especially in the Mediterranean again, 1.5 degrees. As you see that how the temperature is going to increase from the 1860 to 2020. And in addition, if you look at some surface temperature waves, as you see in here, especially the south of the Mediterranean, the temperature is going to, the wave surface air temperature is going to be increased. The reach about 50 degrees. And then if you look at the heat waves from just 2021 data, as you see that in here, especially the south of the Mediterranean really have a big problem because the temperature is very high, extreme heat stresses, under heat stresses. And then generally, all the data show that different projections show that in here, the Mediterranean basin will be experienced mean annual temperature about 2 degrees. This is the problem for this region. And then again, if you look at the precipitation value in the different model in here, as you see that in the degrees in precipitation are projected to reach about minus 30%, while some part of the southern Mediterranean, the rain degrees will be reachable to 40% the annual precipitation. This is the critical for the life system of the region. And then after that, because of these problems, we can see that many natural disaster like flood events, as you see that how the flood event is going to be increased. We come across a big problem in Valencia in 2020. You can imagine in this town for example, in this area, they more than 300 millimeters of the rainfall in the part of the province. Generally, in the Mediterranean, the temperature is going to be increased. Also, the pH of the sea is going to be decreased a little bit, and then sea level is going to be increased, and then this affected the that heritage area, and then also the minus 30, the rainfall is going to be decreased in this region. And then if you adjust that quickly, if you see that all this region, they have many activity, for example, marine ecosystem, terrestrial ecosystem, water, and all this one affected by the climate change at that time in this region. And then if you look at the side, that the water withdrawal by sector, as you see that countries will be changed, but in this part, you see that most of them used for the agricultures, but in this region, especially the north part of the Mediterranean, they use for the industry. But generally, especially south of the, most of them is used for the agriculture. If you look at the sectors, you know that each countries, you see that each country is different. For example, the Korea, as in here, they more the domestic use. But if you look at it like Egypt, about most of them is from use for the agricultures, and then sometimes for the cooling water, the meaning that used for the other industry system. And then in some countries, it's dependent on the other countries' water, the meaning that transboundary water resource. For example, in this some part eastern the Mediterranean region, some countries, the pink colors, this meaning that the dependent on the other countries' water resource. Okay, like the some also the north of the Mediterranean. And then generally, water resource and quality decrease, water demand increase in this region. About 180% people in water scarcity in this region. Water availability is the, you know, that about 72 and 74% renewable water resources are located in the northern Mediterranean region, but still south is a problem. And then if you look at the seafood production and other under the treaty in this region, and then also the drought extreme events we can be seen in the Mediterranean region. And then this is to show that the water resources stresses level, especially the red one is the extremely high stresses in this region. This is critical in this part. And then if you look at the soil surface soil moistures, about 1 and 10 centimeter, especially the brown color is show that the drought, you can see that in north, especially north, and then also some part, they have a, you know, that problem with the soil moisture, the meaning that the no enough recharge. And then if you look at the, you know, the topsoil for like from 0 to 40 centimeters, and then low content, especially the south of the area, they have a problem. A drought is, you know, it's a big problem for the system. And then they collected many groundwater level. They measured the water level, groundwater in the different part of Earth. This is some sample. But if you look at the generally, especially most of the aquifers under the risk, all the data show that the aquifers under the risk, especially the arid region, arid and semi-arid region, they have a problem. The high arid region, you know, that maybe the aquifers is like about like a 40% is going to be decreasing the size. And then the recharge is a critical point, but we can see that the recharge is going to be decreased again in these regions, but also the more evaporation in the Mediterranean region. This is the problem for the next generation. And then seawater intrusion is one of the big problem. And then especially the coastal region area, we have recharge is low, more people, and then more extraction. The groundwater level is going to be decreased in this area. The hydrogeology is very complex in this region, but generally in the south of the Mediterranean region, they have a high productive aquifers, but the problem is this aquifers affected by the seawater intrusion. This is the other problem. And then we can see that in almost all countries, the greatest part of the abstract groundwater is for the irrigation, about 80 and 60%, like Spain, Cyprus, Syria, Israel, Libya, and Tunisia. More than 50% in Italy, Greece, and Turkey also. And then this is to show just some maps about the groundwater, the application in the different region, and then recharge. You see that we can see that more recharge in the north of the Europe, but in the Mediterranean, especially south of recharge level is very, very, very limited. And then again, in the red, you see that in red dot, this meaning that mean groundwater abstraction, that more groundwater abstraction will be, especially in the coastal region. This is the big problem on the area. And then again, this is the mean trend of the, groundwater, the drive groundwater in the European Mediterranean region for period 2002, 3 and 2020. As you see that mean trend is millimeters per annual. And then you see that this part is a minus like a 27 and then a minus 30. This is the risk, big risk in this region for the recharge system. And then generally, if you look at all of this data, about 70% of region shows significantly negative groundwater trend, while 20% in positive. And then also the groundwater trend region is like, minus 2.1 millimeter per year. Yeah, okay, this is the let's say. Again, for example, and then if you look at this one, you can see that in here there have been a serious decrease in groundwater level in the basin in the recent years. Like this part of the groundwater level is going to decrease related to the time. And then you see that some wells in here, monitoring wells. You can imagine at that time in 1965 a -20, but now is minus. You see that more than -60. Okay, again you can see that all the trend is going to be decreased. The meaning that groundwater level going to be increased, decrease in the many places. Like Morocco, you see that related time groundwater level going to decrease. Lebanon, Spain, you see that again. You see that Tunisia, the groundwater level is going to be decreased with the time. Okay, therefore we have groundwater is very critical because the surface water affected by climate change. Therefore, we have to protect the groundwater resource. We have to sustain it very well. For this one, we have to do some things. We have to reduce losses. We manage water demand. Treated polluted water is very critical. We reuse your water. We have to go to focus about more deep aquifers. Artificial recharge underground dam is very popular. We have to think about Mediterranean region. We have to display that that all this water we have to use again and again. Okay, monitoring is very critical. Therefore, we use the digital groundwater system monitoring, and then satellite image very important. We have to use the new satellite. We have to model all the sites very well, and then we have to improve the smart irrigation system. Still, we have a big problem in the Mediterranean region. We have to improve these sectors, and then we recover of the atmospheric water. In addition to, we have used effective renewable energy in the water resources. This is okay. Generally, in the completion, we have used efficient resource utilization. We have to think about the dynamic decision criteria, make about this one. We use the high technology. We have to think about the recharge methodology, ecologic, nature-based solution, and then we have a comprehensive measure, and then we have collected all the data and model achievement. This is very critical for this region. As you see that the Mediterranean risk, especially under the big risk, we have to minimize this risk. For this one, we have to manage very well. Thank you very much for your attention.
Thank you very much, Professor Dr. Alper Baba, for your insights. Thank you very much for sharing your findings with us, and thank you for attending our conference as well.
Thank you very much. Thank you.
So our next presenter is Professor Dr. Huang.
So, hello everyone. Thank you very much for inviting me to join the very interesting conference. Actually, I'm in China. I've never been in Mediterranean region, but I hope the topic I bring today would help us to understand more about the climate change and also what the risk we are going to face in the urban area. So let's start. So give me a second. Let me start the screen.
Professor Huang, down there you can see a present button. From this present button,
yeah,
you can share
is
your
helping me. So yeah, so come over here.
Hello, Professor Doctors. I will help Professor Huang to share the screen. Okay.
Yeah, from present button you can share the screen of your presentation.
So I think it's
okay. So it's okay now. So you can see my screen, right?
Yes.
So today,
right. Okay.
yeah. Okay, great. Actually, I also invite my former PhD student right now. He's Dr. Xiaotong Zhu to come to join the conference. So if there's any question, we can answer together. So today, my talk is integrating SAR imagery with social media data to improve flood monitoring, a machine learning approach. That's the introduction for myself, and also here, that's the introduction for Xiaotong. So can we stop the automatic? Before we start, I would like to talk about the climate change. So we can go, okay. So the previous presentation, many professors already talked about the climate change. So I would like to talk about more about the flooding. Because flooding seems right now globally is more extreme and more frequent. For example, here I only represent some flooding in Beijing, Zhengzhou, and Seoul. But I heard also there's big flooding occurred in Dubai this year, probably in April. So we can see flooding actually happen everywhere right now. So actually this study, we using the extreme event occurred last year. So right now we gave the name is 237. It means, so it's the first one, what happened in Beijing, Tianjin, and also Hebei province in China. That's occurred in late July and the 1st and 2nd of August. That's the last one. So we can see the extreme rainfall that's in the Beijing, Tianjin, and the Hebei province, and the caused severe flooding and affect over 5 million people, and resulted in the direct economic loss is about 96 billion. So that's the rainfall. That's the rainfall fall in Beijing. You can see here, there's about 1 meter rain. That's just in 3 days. So what that means, actually, Beijing and Tianjin and Hebei province, the annual average is about 500 to 550 millimeter. So this means in only 3 days, there are 2 years total rainfall fall in that place. So this is the reason why it caused a lot of problem. So now, because we have advanced technology, so we can have a lot of monitoring. So, for example, in China, many cities already have many rain gauge. For example, in Tianjin, the place we're living, we have more than 300 rain gauge around the city, and we also have a lot the water level gauge everywhere in the and the bridge, and also in the river. However, there's still some problem because many of the measurements are point-based. That's the first thing. The second, because the installation of the instrument needs the capital investment and also maintenance. So costs a lot. And sometimes, especially during flooding, this sensor, they may not reliable every time. So this may cause many flood-prone spots are easily overlooked. And when we need to do the loss assessment, When we want to evaluate how much the economic loss due to the flooding, directly due to the flooding, so we still need to send people to the field to do some field investigation. How can the advanced technology solve this type problem? This is why we want to bring the satellite into the place. The satellite actually has in the place for many years. Start from like last century, 1980s. However, many of the sensors they are passive. So this means they like a camera. They can take picture. During the flooding season, one problem is the cloud. So the cloud cover become a big issue. So we cannot see through the cloud. And recently, there's another technology already been developed. That's SAR. It's radar. So this sends the signal directly to the ground. The advantage is the cloud would not affect the signal from SAR. In this study, we use SAR to identify the flooding area. Because this is research, so we use some free resource for the remote sensing image. Now we're using the Sentinel-1. It's launched by a European country. So it has the revisit time of 6 days, and also the resolution is very good. It's about 10 meters. And the second one we can also consider is a GF3. The average revisit time less than 3 days, and the maximum resolution is about 1 meter. But in our study, we stick with Sentinel-1 because the data is free. Let's go to next page. Okay, so here we want to bring you an example how the passive image and also SAR image look like. From here, you can see the regular image is from the Sentinel-2, and they have the true color. And this is the image from radar. So it's Sentinel-1. So this on the same day is June 2023. And here, there's a big reservoir for Tianjin. Is the source water for Tianjin. It's called the Yuqiao Reservoir. So you can see the color is different. Here, the true color is green, and here inside image is black. So this is how we identify the water area, because the water, when the radar signal come to the water can absorb the signal, and then the signal back to the satellite become weak. So that's how that's why the water area become dark. However, here there's one issue is how dark this should be water. So we need to determine the darkness of the area, which should be water, should be identified as water. If you look at here, this urban area, and in the urban area, you will see the buildings and also some man-made structures, bridge, road. They may also have the highly reflective of microwave signals. So sometimes they have the bright color, but sometimes they may have they may have the impact on the area we want to identify. That's the water area. So so if the water area adjacent to this very bright area, then the image they may mixing the the signal. So they may have the impact on the identification, accurate identification of the water area. So that's why we need to determine where is water. So we need to get the ground truth from the we need to get the ground truth. We need to get the sampling for the ground truth. So this is the issue. We talked about before. Right now, we have a lot of monitoring stations. Like we have the water level gauge. So this can give us some information. However, so for example, like this Tianjin. Tianjin is about 10,000 square kilometers. So if we only have like 300 water level gauges, probably it's not enough. And because they are all point data. We want to establish a model which we can use always further to identify the water area, not only once. So we want to use machine learning to build up the model. However, if we want to use machine learning, then we need a lot ground truth data to train the model. So what we can do, so that's the challenge we're facing. We already talk about, and also people probably familiar with the flooding risk map. Sometimes we call flood risk mapping. The normal way to do flood risk mapping is use modeling. For example, we can use HighGrass. So we have the cross section for the river, and we build a model, and also we apply some artificial rainfall. For example, we may apply for like the 10-year return periods rainfall or 100-year return periods rainfall, and then we got the flooding area. However, that's only for river. In the urban area, sometimes we also need to consider when the underground pipe is full and the surcharging from the manhole. However, the conventional flooding risk mapping cannot do that. They can only do the channel and either man-made channel or the irregular river channel. So if we want to do the inundation mapping, then we have the problem. We cannot use the conventional way to do that. So that's how we come up to use the remote sensing data to do the inundation mapping. And also we want to do the inundation risk mapping. So we already bring out the issue is the sampling. So if there's flooding, so we may go to the field to take sample. However, because the limitation of how many labor we can send to the field, so there's always like a bottleneck for the machine learning model. Then we come up idea because right now people actually we all in China, almost everyone has cell phone. So cell phone become very convenient, and sometimes it can be used as sensor. For example, if there's a big flooding, and people may drive on the street, and sometimes they might be trapped in somewhere. They cannot go anywhere. So people like sharing, they may take a picture and tell their friend, tell their relative in the family, and tell them, oh, please do not come here because there's a big flooding and I cannot drive through. And they may post that on like YouTube. They post that on the in China we have the WeChat, and in other countries they may have the TikTok, or they may post on Facebook. So they give us a way to interpret this data. We can first we can catch this information, and then we can interpret this information. So we call it the social media data, especially during extreme event. So you can see here this what happened in last year in July, the late July and early August. There's a big rain in Tianjin, the city we are living. So you can see many cars actually trapped on the street. They cannot drive. So sometimes they take a picture on the street. So this the picture. Actually, we now can access 4 different social media database. One is TikTok, one is YouTube, and also we called 今日头条, and some others. So in total, we can access 4 different social media database, and then we collect a lot pictures and also videos, and we also need to do a screen. Because sometimes when we use the keyword, we found sometimes we may capture the image. It's not only for this extreme event. This might be 2 years ago. This might be an event 2 years ago. So we also need to have a screening process. So we develop algorithm. First, we need to use the keyword and to capture the image. And the second, we need to do a screening to locate the rainfall. It should be exactly the rainfall we're looking for, the rainfall event we are looking for. The third, we need to do the location. So we need to pinpoint this location. So we need to find out where the picture is taken. So the picture can tell us, see here, there's a flooding. Here, this water. So we can identify the intersection in the picture where it's taken. So this for Tianjin. So when we do it, we collect for last year's extreme events in late July. We eventually got 6,800 sampling data for the ground truth. So that's very good for us to establish the machine learning algorithm for the remote sensing data retrieval. So this also the example of social media tags related to flooding. So you can see here, this results. This for the entire Tianjin, we identify the inundation area for the day of July 31. So you can see most of the area in here is black, and here also dark blue. We have to say dark blue. Yeah, here is also dark blue. This rural area, and here this the urban area. We use 5 different models to extract the water area. So including the support vector machine, and also actually boost. And here, that's the one is the ensemble machine learning framework. So this means we use the 4 different machine learning algorithms, and we run the model. We also come up a comprehensive evaluation of fitness functions. We have a bunch of index to evaluate how good the data, the model, or the results is. And then we use a certain standard to ensemble them together, and then come up the final results. Once we build that model, then we can to try to establish the historical database. So in our study, we use the period from January 2014 and to November 2023. So that's about 5 years. So we use this model we build up for the extreme events, and then we try to retrieve the water area for other events in the past 5 years. And then for each pixel or each grid, we accumulate the time when the flooding occur. So then we can get a frequency for each for each grid or each pixel. If this grid has more frequency of flooding. So this the idea. If we go to the results, we can see the proportion of agricultural land in the inundation area range from 54 to 56. And the urban area, because they have the largest impervious surface, however, is lower. It's only 32 or 30, it's around 32. So this means actually the urban drainage infrastructure works very well. So works much better than the rural area. And also we should say there's still a challenge, because in the rural area, people normally when they're very less time. So we have very few sampling data in the rural area. This may also affect our results. And eventually, we published the paper, and during the time of submission, we got some excellent review comments come back, and they asked us to do some comparison of accuracy, recall, and procession of the model with different scale of training data. We do lack it. So you can see if we use the social media data, the accuracy actually is very good. However, if we took off the social media data, then you will see the accuracy dropped dramatically. We published the paper this year in the Sustainable Cities and the Society. So if anybody have interest, you can also go to see our paper. We want to see if we can use this methodology to some other area. So in this year, in August 1st, actually that's in Hunan province, about 1,000 kilometers away from here, they experience very extreme rainfall. So you can see the daily rainfall, and then they reach high as 96. That's a mountain area. We also do sat image flooding area retrieval for this area. So that's the sat image we found. That's July 28. And then here, there's the red area as the flooding area we identified for this city. And also here, there's some important water body. So come to the conclusion, we found the social media data can significantly improve the accuracy for the remote sensing retrieval of water area. And so the methodology we developed here can address the data inefficiency issue. And also, we hope this method, once they use more and more frequent, we can developing more accurate risk mapping for flooding by using the historical rainfall event. So we think this probably will be the future for this method, and also we can improve the inundation mapping largely by using the remote sensing method. Okay, thank you very much. That's all my talk.
Thank you very much, Professor Huang. It was very nice presentation to listen. It was very nice to hear your findings. Thank you very much for your contributions to our conference.
Okay. Thank you for inviting us.
Our next presenter is Dr. Ahmed on behalf of Nihal Bektaş.
Yes, hello. I shared my screen. Did you see my screen now?
Yes, you should open your presentation as well.
Yes, I open it and share my screen.
Right now we are seeing your folder. We are seeing your folder. You are yes. Right now it is okay.
Yes,
it's
I
perfect.
can start now.
Yes, hocam, you can start.
Yes. Hello, everyone. Good morning. My name is Ahmed Al-Bahnasawi from the Environmental Engineering Department at Gebze Technical University. I am going to present in behalf of Prof. Nihal Bektaş, the head of department. So today I am excited to discuss the next generation water treatment technologies with a focus in two innovative approaches. The first one is green chemistry for sustainable water treatment. And the second one, I am going to share some technologies in biotechnology, which include bioremediation. As you know, in face of increasing water scarcity, pollutions, and population growth, and a lot of climate change issues, as the presenter in this conference discussed before, it's critical to explore sustainable solutions that can meet the growing demand for clean and safer water. Before diving into the innovative, let's briefly discuss why traditional water treatment methods face limitation. The first issues is energy intensive. A process like filtration and dechlorination requires significant energy, and a lot of treatment methods, water treatment need a lot of energy. The second issue is chemical prevalence. They often rely on chemicals that can cause environmental harm and health risks, like chemical coagulant, for example, iron and aluminum salts. The third one is inefficient contaminant removal, especially for emerging contaminants like pharmaceuticals, microplastic, and the least days, PFAS. These traditional water treatment methods maybe need a lot of energy and chemicals to use, which increase the cost of using these traditional treatment methods. Now let's talk about the first approach, green chemistry. Briefly, I will talk about the green chemistry. Green chemistry aims to minimize hazardous chemicals and reduce environmental impacts. There are 12 principles of green chemistry. Of course, green chemistry not just for water treatment. We can use green chemistry in a lot of industrial issues and sectors. But what we use in water treatment may be 6 or 7 principles from 12 principles. Let's talk about the principles that we use in water treatment sector. The first one is preventing waste rather than cleaning it up after it's produced. For example, we can use bio-based coagulants extracted from plant, animal, or microorganism sources instead of chemicals ones, for example, iron and aluminum salts. And the second principle is atom economy, which maximizing the incorporation of all material used in the process onto the final products. For example, we can use green advanced oxidation process like using hydrogen peroxide or ozone to degrade the organic pollutant. The third one is list hazardous chemical synthesis. We need to design a chemical reaction that use and generate substance with minimal toxicity. Again, we can use hydrogen peroxide and ozone instead of chlorine-based disinfectant, which the last one, chlorine-based disinfection, produce byproducts, chlorination byproducts, which is harmful for environment. The fourth principles we can use in water treatment is energy efficient, reducing energy consumption in water treatment. Maybe use solar panels or renewable energy as a power source for treatment plants. It can be one of the solution. For the fifth principle, safer chemical, using chemicals that are less harmful to environment and human. Again, maybe we use biocoagulant, biocertificant, maybe using ozone and hydrogen peroxide instead of harmless chemicals. The last one is developing a process that are resource efficient, cost effective, and environmentally friendly. Maybe these principles can summarize all the above principles. After that, I am going to talk about some, actually I talked about some examples for green chemistry and water treatment. For example, sustainable chemical synthesis replacing traditional chemicals process with more sustainable ones. Also, I am going to talk about nanotechnology-based solution, especially the bio-based nano materials. For example, we have we can extract some nanoparticles that can use in water treatment from a plant. For example, we can extract titanium dioxide from green tea and so on.
Dr. Ahmed, we just had a technical problem with your presentation. Can you please open your turn off your presentation and open it again from where you left?
I need to stop sharing and start sharing again.
Yes, exactly. Just directly close your presentation and open it again. Do the whole procedure from the start, from the beginning, and
which
you can
slide
continue where you left off.
Yes, now. Okay. Now you can see my presentation.
Yes, Hocam. Is this where you left off? Can you please choose the correct
Yes,
slides?
I will go to the this one. I think green chemistry and water treatment.
Okay.
Yes.
Hocam.
Did you see the previous slides?
Some of them yes, some of them no, Hocam. Unfortunately.
I am sorry for that. I can see it and I can summarize it when I talk in the next slides. No problem. Okay, so we talked about some green chemistry principles and talked about some examples that we use in green chemistry for water treatment innovation. For example, for sustainable chemical synthesis, replacing traditional chemicals process with more sustainable ones. As I said, we can replace the chemical coagulant like iron and aluminum salt with biocoagulant extracted from plant animals and microorganisms. Also, we can extract some nanoparticles from plant such as titanium dioxide, which has some photocatalyst and advanced oxidation properties from tea. Also, we can use some advanced oxidation process that use hydrogen peroxide and ozone instead of chlorine disinfectant, which, as you know, chlorine disinfectant can produce many byproducts, harmful byproducts for environment. Also, we can use membrane technology, but we need to decrease the cost of energy for membrane technology. Maybe we can do that by using renewable energy resources from solar, wind, geotechnical energy. Now, after that, also I talked about the green chemicals and water treatment. In a brief, we can use bio-based certificant, oxidant like hydrogen peroxide, ozone. Also, we can use nanomaterials, specially extracted from plant-based one, like titanium dioxide, which act as a photocatalyst, breaking down organic pollutant using sunlight. Also, we can use the bioadsorbent like activated carbon or biochars derived or extracted from renewable sources like coconut shells or any agricultural waste. We can convert it to activated carbon or biochar by pyrolysis or any such methods. Maybe these methods can be energy. It's need high energy, but we can, as I said, search for a new renewable energy. Also, I talked about bio-based coagulant polymers extracted from plant, animals, or microorganism can be valuable using in coagulant and flocculation, coagulation and flocculation process instead of chemicals. After that, we will talk about the second approach, bioremediation, a biotechnological solution. Specifically, we will talk about phytoremediation and microbial fuel cells and enzymatic pyromediation also in brief. As you, pyromediation technology leverages the power of living organisms to clean contaminated water. Microorganisms, particularly bacteria, play a crucial role in breaking down pollutants through nature process. Also, we use in conventional treatment process like anoxic, anaerobic, and aerobic tanks. Also, we can use plants that are utilized for phytoremediation where they absorb contaminant from the soil and water. These biotechnologies methods provide environmentally friendly and cost-effective alternatives to traditional water treatment technology. Let's start with phytoremediation. There is a lot of plant actually, but I give two examples or three examples here. Certain plants like sunflowers and olive flowers absorb heavy metal such as lead, mercury, and cadmium. After that, we can get rid of this plant in such safer way. Also, aquatic plants like duckweed remove excess nitrogen and phosphorus, preventing algae blooms. Actually, this technology is very promising in terms, especially of heavy metals removal. We can remove the heavy metals from soil, the upper layer from soil. The second one is microbial fuel cells. I think it's under research until now. There is no any pilot scales or full scales for microbial fuel cells, but it's promising. A dual function approach where bacteria treat wastewater while generating electricity. There is a lot of research about the microbial fuel cell methods. I think it's a promising one, but it's need more and more research and enhancement. The third one is using enzymes-based water treatment. Enzymes like lactose, there's a lot of enzymes actually, but enzymes like lactose and products target specific pollutant, including pesticides and pharmaceutical and industrial chemical. Enzyme-based technology offers a sustainable alternative to traditional chemical treatment, minimizing the generation of harmful byproducts. That's an important issue. Also, I think this technology needs more and more research. Actually, all green methods for water and wastewater treatment need a lot of research to get this technology to the full scale and to get this technology for the to the practice. As you know, comparing what I need to say here. While green chemistry and bioremediation offering promise solution like reduced toxicity, energy efficient, and sustainable material use and cost effective, but there's a lot of challenges actually in some. For example, the cost and scalability. Scaling up this technology for a large scale can be expensive. Also, we have some issues with public precipitation and regulation. Establishing guidelines and gaining public trust is essential for widespread adaptation. Also, we need to a continuous research and development are needed to get these green methods to full scale. Also, I think in terms of nanomaterials extracted from green resources is promising and can easily get this technology for full application. Also, we need some policy and regulation for green water treatment. We need to abandon the use of harmful chemical first and try to use the green ones. Let's talk about the future of water treatment technology. Nanotechnology are proving to be effective for removing pollutants, especially for that extracted from plant-based or animal-based resources. Because nanotechnology, as you know, nanomaterials have two unique properties. The first one is high surface area and which means high reactivity, and the second one is quantum effect, which means that we can use nanomaterials at a quantum scale. For artificial intelligence, you know, every sector now use artificial intelligence. Also in water treatment process, we need these tools for predicting potential problems. In sustainable solution, we need to emphasize on renewable energy and reducing environment impact. I think the future of water treatment technology can be summarized in these three approaches. We need a lot of research. We need to search for nanomaterials, synthesis and characterize nanomaterials. We need to include artificial intelligence tools in our process. Also, we need to search for sustainable solution which emphasizes on renewable energy to reduce environmental impact. Actually, also we need the collaboration between science, industry, and policy for a new green technologies for water treatment and wastewater treatment. That's what I want to say today. If you have any question, you can email me. This presentation, as I said at the first, in behalf of Professor Nihal Bektash, the head of department, and also with cooperation with Associate Professor Murad Evas and me, Ahmed Al-Bahnisawi. If you have any questions, I am ready to answer your questions. Okay.
I would like to thank the organizers for the kind invitation. Today, I would like to talk about climate change and how climate change affects the services that the seas and oceans provide and the effect of these on human security. And I will start my talk with talking about how the risks from climate change occur and how marine research contributes to human security under the changing climate. And I will talk about a few projects that we are working on. And the first one is on the One Health approach in the Black Sea. Then I will talk about the safe operating space and the digital twins of the ocean for human security and multi-purpose offshore platforms that we are designing. To begin with, I would like to briefly introduce myself. I'm an oceanographer, and my researching interests include ecosystem modeling, physical oceanography, blue economy, climate change, and sustainable development. And I'm the director of Middle East Technical University Institute of Marine Sciences and Middle East Technical University's Climate Change Center. My institute is located at the Mediterranean coast of Turkey, and our campus was operated around 50 years ago. So we have 3 centers in the campus. One of them is the Institute of Marine Sciences. That's a graduate school. Our main center is DECOSIM. That's the Marine Ecosystems and Climate Research Center. That's how we maintain our infrastructure. And recently we have established the Climate Center. Our areas of exploration include the effects of climate change and other stressors on the marine ecosystems. And also more and more we are working on blue economy and socio-economical aspects of it. And marine ecosystems, they provide many services to us. And some of the services include for example, food security from the oceans and energy security. The renewable energy from the seas is one of the biggest or fastest growing sectors, and also health security from the oceans. But that's not the only services that the oceans provide, but they also provide regulatory services like the water security and the climate security. As you may know, the oceans and the seas are the main actors that regulate the water cycle and the climate cycle. And we contribute to several projects towards human security. And I will talk about these projects mainly focusing on environmental security, economic security, and contributing to health and personal security. The year we are in at the moment, that's almost over, 2024, is going to be the warmest year that's recorded. And it will be the first time that we are going above 1.5 degrees. As you know, it's one of the thresholds for the IPCC. And for the last 47 years, the Earth was considerably warmer than the average. And the effects of climate is not only warming, but it has many effects. And one of the striking effects is that last year, it has been observed that trees and land absorbed almost no carbon dioxide. And the situation on the seas is unstable as well. So this is quite dramatic because the main actors that absorb carbon dioxide from the atmosphere and bury to the deeper waters is the biological carbon pump in the oceans. So the little microscopic plants at the surface, they photosynthesize, and at nighttime, the biggest migration in this planet occurs, and microscopic animals migrate to the surface, graze on these plants, and they migrate back to the deeper waters. So this cycle absorbs the carbon dioxide from the atmosphere. And up to now, 25% of the anthropogenic carbon dioxide was absorbed this way, but this cycle is also not stable. So what can we do? We have developed the Black Sea Connect project and the One Health approach. As you may know, Black Sea is one of the seas where many different stressors are acting on the ecosystem. Of course, climate change is one of them, but overfishing, eutrophication, acidification, sea snot, chemical pollution, invasive species, and deoxygenation are the others. So in order to achieve a healthy sea, we needed to develop some management plans or governance plans for the sea. To do that, the Black Sea Connect project was funded, and this was one of the first projects funded under in this field, and I was the coordinator of this project. So under this project, we have developed the Black Sea Strategic Research and Innovation Agenda together with its implementation plan. And its implementation plan included many concrete cutting-edge science and technology actions, starting from digital twin of the Black Sea, going all the way to ecosystem-based fisheries, aquaculture, mariculture, blue biotech, healthy and safety for the Black Sea coast, marine litter, and marine renewable energy. And I will focus on health and safety for the Black Sea coast. So under this theme, we have developed the One Health approach and improved safety for Black Sea coast. What we have considered here is the well-being of coastal populations and the resilience and health of the marine coastal ecosystems. So we have identified that climate-driven extreme events has the potential risks for marine geohazards. And as I said, the effect of climate change is not only temperature increase, but also sea level rise, coastal floods, geohazards, and other stressors include pollution accidents, even armed conflict in the Black Sea. Available monitoring, research, and innovation tools needs to be better mobilized to understand all these effects. Changes in extreme weather events is highly increasing. And with global warming, the probability ratio of how these events will occur is anticipated both under the best scenario and under the worst case scenario to increase. The probability ratio under the worst case scenario is around 20% increase, and under the worst case scenario, this goes up to 60-70% increase, which means that a very high increase, which will have considerable effects in our seas and the oceans, and this has many consequences both for the ecosystem and the economies. Okay, for better governance, under the Bridge Black Sea project, we have developed the digital twins of the oceans for human security. Digital twins are being used more and more nowadays, starting from their areas of applications vary from the health applications for the human body to all the way to Earth system sciences. And they contribute to environmental security in terms of climate change and mitigation or biodiversity conservation, food security in terms of sustainable fisheries and aquaculture, regulating or governing job security or better managing sustainable development of blue economy sectors. And through digital twins, you can also develop better knowledge and governance options. So to develop a safe operating space in the Black Sea, we are utilizing these digital twins. To develop a safe operating space in the Black Sea, we have considered the planetary boundaries that are applied to the Black Sea. As you know, planetary boundaries, they have been developed for the globe, and we have already passed the boundaries for many different impacts that are identified here. And for the seas, we are identifying new boundaries, and we are analyzing how we can stay within the safe operating limits for these boundaries. To do so, the Black Sea Bridge project has developed 3 nodes. The first one is service dynamics, understanding the ecosystem services that these seas provide to us. The second one is blue growth incubators, and the third one is empowering citizens. And the digital twin includes different scenarios that we develop. So we are testing different scenarios. These scenarios are not only climate change scenarios, but it includes the different socioeconomic scenarios. And we are carrying out resilience analysis. And through different ecosystem models, we are developing adaptive management options for the Black Sea. And the digital twin considers the Black Sea's physical features, its ecosystem, its socioeconomic aspects, and as I said, develops management options. So the core of this digital twin is how we model the ecosystem of the Black Sea, which starts with a physical model, and which this fully coupled physical ecological model, we have tested different IPCC climate change scenarios, SSP 1, 2.6, the best case scenario, and the SSP 5, 8.5, the worst case scenario. And these are very new results. And when we project it for the next 90 years or so, we have seen that under the worst case scenario, the temperatures are going to increase almost 30% in the Black Sea. And this has implications on the ecosystem, and the primary production is considered to drop considerably, and dissolved oxygen levels are approaching to the surface. So, and lastly, I would like to talk about the use of technology in order to mitigate and adapt towards climate change and support human security. And one of the recent emerging approaches is the multi-use ocean platforms. And we have developed a project for the Turkish seas, where we have brought together the industry and the academics to tackle this challenge. And under this project, we have 5 pillars. The first one is on developing sea technology platform design for different seas, including the Mediterranean. The second one is developing a prototype. This will be developed for the first time for the Turkish seas. Under the third pillar, extracting of raw materials and hydrogen from the sea. Fourth one, blue biotechnology and food production from the sea. And the fifth one is sea platform observation data and digital support systems. How does this contribute to human security? It promotes public health through renewable energy, zero carbon, clean energy production from the sea, including the sun and the solar, as well as green hydrogen for clean energy, industrial health benefits, and medical source supply. And it supports environmental security through smart observational systems, marine protected areas integrated with digital twins. And blue biotechnology and food production include pharmaceutical discovery, nutritional supplements, alternative protein sources. So with this, I would like to end my talk. I hope I managed to provide a vision towards healthy and more secure systems. Thank you.